Hello students. Previously we have seen how exactly AVL tree is created. So according to balance factor we have to do. Okay. So now let's see the example of AVL tree, how it will generate it. Fine. So the example is we have to insert this element, means we have to insertion operation also to perform. So insert 14, 17, 11, 7, 53, 4, 13 into empty AVL tree. So for AVL tree making, it is for it's actually the BST. So no doubt the root node is 14 and 17 is less than 14. So it sorry greater than 14. So it should be going to the right side. Okay. So according to that, we have to make the tree first. Okay. So now we'll see the example here. Okay, so root node will be the 14 here. Okay, now next 17 is greater than 14, so it should be placed in right side. Then 11. Okay, after inserting element, we have to check the balance factor of each and every node. So we are calling it as a balance factor of 14 node. So just check here. This is a balance factor of 14 we are going to check. Okay, equal to height of left subtree minus height of right subtree. So it is what 1 minus 1, the height of left subtree minus height of right subtree equal to 0. So it's balanced, so no issue for AVL tree making. Okay, if the tree is imbalanced, then we have to rotate it. So how it will do, we have to focus on that part here. Okay, fine. So now let's concentrate on next part here. Okay, just see, we are inserting 7 here. Again, we'll check 7 we are inserting. 7 is lesser than 14. So that's why it goes into the left side. But there is a 11 is already child is present. So it is again placed on left side of 11. Okay, so now check the balance factor of each and every node. So balance factor of 14, just check here. The balance factor of 14, what happens is here. So the balance factor of 14, 2 minus 1, that is 1. Okay, so there is no any change in balance factor. Okay, so means tree is not imbalanced. So again, no issue. Now we'll insert the next node here. Okay, so we are going to inserting the next node. Okay, 53. Again, check the balance factor of 14. So the height of 14, let's say the 2 minus 2, again balance factor of 14 is 0. Okay, so here we can write 0. Balance factor of 11 is 1 minus 0, because 11 doesn't have right child. So it is 1. What about the 17? 0 minus 1, that is minus 1. What about 53? It is 0. Leaf node. Okay, again 7, that is height of left subtree minus height of right subtree equal to 0. So tree is AVL tree. There is no any imbalance there. Okay, so now we inserting the next node here. Okay, so we'll focus on next part. Okay, so next we are inserting 4 element. Okay, fine. So we are going to inserting the 4 element here. So just check the balance factor. Okay, so we have inserted it. So check the balance factor of 14 here. Okay, so we are going to check balance factor of 14. So again, this if you are checking balance factor of 14, just concentrate here. That is 14 is having what? These are the balance factor. Okay, this is 1, 2, 3. 3 minus 2, that is 1. Okay, what about 11? 11 having balance factor, that is height of left subtree, that is 1 to 2 minus 0. There is doesn't have any right subtree, that is 2 minus 0, that is 2. Means here the 11 having some problem to balance. It means there is imbalance tree, because the balance factor should be 0, 1 and minus 1, but it is 2. Means we have to rotate that tree. What about 17? 17 again 0 minus 1, that is minus 1. What about 7? 7 is 1 minus 0, that is 1, that is 0, and this is again 0. So where is the imbalance tree is? 11. So what exactly we have to do here? So we have to perform the rotations here. So how we are going to rotate that tree? Now we'll focus on that part. Okay. So just see here, there is imbalance given. So how we are going to rotate it? So we have to rotate likewise. How it is possible? There are 4 rotations: LL, LR, RL and LL. So what exactly it is that we need to focus on one by one. Okay. So basically we focused on that. So this type of rotation, because here is rotations is required, and the type of rotation is are called as, this is LL rotation. It is called as LL rotation. There are total 4 rotation types. So types of rotations are 4. That is, first one is LL rotation, then RR rotation. LL means left rotation, then RR rotation, then LR rotation, that is left to right, and RL rotation, that is right to L. So total basically 4 rotations are required for AVL tree. Okay, so why we are rotating it? Because we have to balance our AVL tree is, because it is imbalanced. So balance factor is, it is 2. So sorry, balance factor should be 0, 1 and -1. That's why here we have to rotate this tree. Okay, so this rotation comes under into the first rotation part, that is LL. LL means left. So we have to rotate this. So what is the formula of LL for rotation? So always remember that for LL rotation, middle node should be goes to the रूट नोड, एंड जो रूट नोड होगा रोटेट करना है. सो वी हैव टू रोटेट इट इज इन क्लॉकवाइज. ओके, so when we are rotating clockwise, so 17 will be the root node, and no doubt 11 is greater than 17, so it should be placed on right side, and 14 is less than 11, that's why it should be placed on left side only. Okay, so now we'll see that example so that you can easily understand this point. Okay, so you can see here the next, yes, this is the rotation that we have performed, LL rotation. Again I am repeat, there are 4 rotations: left rotation, LL rotation, RR rotation, RL rotation and LR rotation. So first we have done LL rotation, means we have to rotate tree as a left. Okay, clockwise. So there is, again we have to check the balance factor now. So after rotating the tree, we have to check the balance factor here. So the 7 balance factor is what? The balance factor of 7 is 1 minus 1, means balance factor, height of left subtree minus height of right subtree, that is 1 minus 1 equal to 0. Okay, and what about balance factor of 17? That is 0 minus 1, that is -1. This is 0, and this is again balance factor of 14 is 2 minus 2, that is 0. So again here is our tree is balanced. Okay, so after inserting 53, 4, only 13 node is remaining. So we'll see how next operation is performed. So I hope everyone clear now. According to this example, you can easily understand how to create AVL trees. Okay, so the next point will be, we have inserted 17 here. Okay, so just check again after inserting 13, the tree is imbalanced. Now check. So the balance factor of 14 here. Okay, so what is the balance factor of 14? So you can now we have seen that 13 we have inserted. Again check the balance factor of each and every node. So we have inserted 13 here. So first we have to check the balance factor of 11, 17. Okay, so now we have inserted 13. So balance factor of 17 will be 1 minus 2, that is -1. So no need to rotate. 11, that is 0 minus 1. Again it is -1. This is 0. And what about this? This is again 0. And the 14 is 1, 2, 3. Okay, 3 minus 2, again 1 balance factor. This is again -1, and this is 0. So according to that, till our tree is balanced. Okay, so according to that we have done it. Okay, now we'll see, suppose the next node we are going to insert here. So what exactly happened, we're going to see. So now we insert 12 here. Just check now. So when I'm inserting the 12 here, just check the balance factor of this tree. Okay, so here when I'm inserting the element of 12, Okay, 12 inserting, again we need to check each and every node when we are inserting. So we have to check the balance factor of every node. Okay, so just see here the balance factor is means that this tree is imbalanced, so we have to perform the rotation here. So check the balance factor of this 11 first. So just check, the 11 doesn't have any right child, it is having only the left child. So 0 minus, this is, let's say there is no any child, so just check 0 minus 2 means the value will be the 2 here. Okay, means the balance factor equals to 2. Balance factor 2 means the tree is imbalanced. So how we are going to rotate it? So just concentrate which type of rotation are there. This is what? This is R L rotation. This is right side and this is left side. So what we have to do here? So RL rotation, how we are going to perform this operation? So for balancing this tree, we have to do just rotate this tree. Okay, so just 12 keep here. 12 कहाँ आना चाहिए यहाँ पे, और 13 कहाँ शिफ्ट होगा, नीचे शिफ्ट होगा. मीन्स आर एल रोटेशन में ऑलवेज रिमेंबर दैट फर्स्ट वी हैव टू डू द आर. फॉर आइडेंटिफिकेशन पर्पज दिख कैसे रहा है, ये राइट साइड है उसका लेफ्ट है, तो आर एल रोटेशन होगा. बट एक्चुअली क्या होता है, दिस 12 शिफ्टिंग टू अपर साइड मीन्स राइट साइड. सो 12 ये लेफ्ट है, 13 का चाइल्ड, तो वो राइट हो जाएगा. मीन्स हियर यूर 12. सो 12 यहाँ पे आएगा, मतलब 13 कहाँ पे जाएगा, नीचे जाएगा. मीन्स इट इज गोज डाउन. सो मीन्स व्हाट हैपन एग्जैक्टली, 11 यहाँ पे आएगा, 12 जो लास्ट वाला है वो मिडल बन जाएगा, और ये 13 नीचे राइट साइड में शिफ्ट हो जाएगा. सो अगेन देयर इज सिंपल टास्क. दिस इज लाइकवाइज द ऑपरेशन विल परफॉर्म. जस्ट विल सी using animation so that you can easily understand that part. Okay, so just see here, I'm shifting this element. Just see, yes, according to that RL rotation में क्या हुआ, 12 कहाँ पे था, लास्ट नोड था, बट इट शुड बी शिफ्टेड इनटू द राइट साइड, तो 12 मिडल में आ गया. दिस इज वन रोटेशन वी हैव डन. मींस वी हैव परफॉर्म RL मींस डबल रोटेशन, LR is double rotation, LR is single rotation. So again it's simple, again we'll check the balance factor of 11 also imbalance. Okay, the value is -2. So what we are going to do now, this R should be in root node. Again means we are shifting 11, we are shifting this element into 11 into where, we are shifting this element into downside, and 12 will be the upper side. So here 12 will be the root node and 11 will be the left child and 13 will be the right child. Right child. Okay, so according to that we have done our L rotation. So I hope you're even clear now. We'll see using animation so that you can easily understand this point. Okay, so again we can clear this part here. Just concentrate here. Okay, so just see here, again the balance factor is imbalance, so it should be 12, 11 and 13. Now our AVL tree is balanced. Okay, so I hope you're even clear this part till now. Okay, now we'll insert 8. So how next example we are going to see now. Now, so our tree is balanced. Okay, so now we'll focus on the next node, that is we have to insert 8. So what type of operation we have to do, we'll see. Okay, insert 8 means it is lesser than 14, so it should be placed on left side of 7, but left side of 14. Then again we have to check where it is going to placed according to BST. Yes, so it should be placed on here. So now we'll see, check the balance factor here. Okay, so just see here what type of operation we have to do. Okay, basically we have to check which node balance factor get changed. Okay, so firstly we'll check it. So 7, just concentrating on 7, the balance factor of 7 will be height of left subtree 1 minus 1 2 3. 1 minus 3 equal to the value will be -2. So the balance factor is changed now. What about 12? 12 is having one important part, that is 1 2. 2 minus 1, that is 1. This is 0, means here is not any balance factor change. So what about 11? 1 minus 0, again 1, this is 0. So balance factor is changed for 7 only. So how we are going to deal with this. Okay, so we'll see how which rotation we are going to perform for this task. Okay. Now, so you can easily understand here the very important part is that, so here the balance factor is changed for 7. Okay, 8 इंसर्ट करने के बाद 12 का बैलेंस फैक्टर चेंज हुआ है क्या? नहीं, द बैलेंस फैक्टर इज चेंज्ड फॉर 7. सो जस्ट कॉन्सेंट्रेट ऑन दैट, जो नोड इंसर्ट किया है और किसका बैलेंस फैक्टर चेंज हुआ है, सो वी हैव टू फोकस्ड ऑन दैट नोड ओनली. दिस इज वेरी इंपॉर्टेंट नोट that I'll repeat. When we are inserting the node 8, but the balance factor of upper two nodes is not change, but the balance factor of 7 is changed, so we have to rotate the first two line here, means I am highlighting here. So balance factor is change of 7, so this one and this one should be, we need to consider, means the operation will be the R L rotation we are going to perform. This operation is very important. Balance factor किसका change हुआ है? The balance factor change of 7. So 7 के बाद जो दो steps आएंगे उसको हमें consider करना है. Now you might be thinking that can we change 8 here and 11 there? Not like that. So madam, can be it is RR rotation or LL rotation? No, बिकॉज 12 का बैलेंस फैक्टर चेंज नहीं हुआ है, 7 का बैलेंस फैक्टर चेंज हुआ है. दैट्स व्हाई वी हैव टू परफॉर्म द आर एल रोटेशन. सो आर एल रोटेशन में क्या होगा? व्हाट इज द प्रोसेस ऑफ आर एल रोटेशन? इज आर एल मीन जो फर्स्ट आर एल में देते डबल रोटेशन, मीन्स ये 11 है, 11 को राइट में शिफ्ट करना है. 11 कहाँ आएगा? 12 की जगह पे. सो 11 यहाँ पे जाएगा, और नो डाउट ये 12 कहाँ पे जाएगा? नीचे जाएगा, क्योंकि 12 11 से बड़ा है. This is first rotation, and second rotation will be 12 will be the root of this tree. Okay, तो tree root कौन बनेगा? 12 बनेगा. So we'll see this example so that you can easily understand this point. Okay, so we'll clear this part here. Okay, so just concentrate here this part. Fine. So I hope everyone clear now how the rotation will perform. Okay, so we'll see exactly how it will work using example. Just see here, previous step, there is a balance factor. I'm again quoting, that is RL rotation. Okay, so RL rotation according to that 11 middle ban jayega, then 12 shifting to left, then 11 is root node of this tree. Just see here. So what happens is here, that is 11 is in root node, 8 is lesser than 11, that's why it is placed on which side? Again it is left side, and 12 is greater than 11, so it will be placed here, and 13 will be placed here. So according to that we have to do, and again check the balance factor of each and every node. Okay, so again we'll see here the balance factor should again not change at all. Okay, so what we'll have to do in this case? Okay, so again we have to focus this part, how we are going to deal with this all the points. Okay, so again balance factor, there is change. Now again we have to make a formula, how what type of rotation we have to do here. Okay, now just check, just previous slide, that is again the balance factor of 7 still imbalance, that is 1 minus 1 2 3, again it is what? Minus 2 balance factor. Okay, so again balance factor of 7 is what? After rotating, it is balance factor is minus 2. So what we are going to do here, the balance factor is minus 2 only, so again it's imbalance. So again for that purpose you have to think that how we are going to rotate it. Height balance karna means we have to reduce the height here. Just check here, so previously it should be like this. So what will be the operation we have to perform here? So balance factor, again it is changed, so what we have to do, again RL rotation we are going to perform. Okay, so what is RL rotation? ये देखो फिर से 7 का बैलेंस फैक्टर चेंज नहीं हुआ है, so again this is RL rotation, means double rotation we have to do, means again the 8 will be placed into the 11, shifted to R राइट साइड, एंड 11 कहा जाएगा? नीचे शिफ्ट होगा, 8 11 की जगह पे आ जाएगा, देन 8 11 लाइकवाइज नीचे की सेम रहेगी और रूट कौन बनेगा फिर 8 विल बी द root. Okay, so this type of operation we have to perform here. Okay, so now just check here. This is yes. So we have seen that the 11 is root node and 12 will be the left side. Now check the balance factor of each and every node so you can understand that the tree will be balanced. Okay, tree is balanced now. Okay, so the balance factor of 11 will be 1 2 2 minus 2, that is 0. The 7 0 again, 0 minus 1, that is minus 1. What about 14? 1 2 3 minus 2, that is again 1. This is minus 1, this is 0. So likewise our tree is imbalance, sorry, balance. Okay, so I hope everyone clear now the concept of AVL tree insertion process clearly. Thank you so much, students. I hope everyone enjoyed it.